All right, let's start talking about vectors. What's the definition of a vector? How would you define a vector? It has two properties. It has what? A magnitude, right?
And direction.
And direction. Whereas a scalar is its opposite. Scalar only has a magnitude. So for example, speed, how fast you're going, you have a number, 30 kilometers per hour, 100 kilometers per hour. Speed is a scalar. Velocity is speed with direction. So 30 kilometers per hour north or something like that. That is a measure of, that's a vector measure, basically. Speed and direction. Is there any questions we can do? All right, here's a question. So when it comes to vectors, there's bound to be some similar vectors. Vectors is basically something that brings you from one point to another. That is it. So let's look at this question. We're given a rhombus. Is that a rhombus? It says it's a rhombus. What's the difference between a rhombus and a square? Or are they similar at all? What do you think? What's a rhombus?
Like the angles of the triangles aren't 90 degrees.
Yeah, exactly. They're not perpendicular. It's the same thing as a square. The side lengths are the same, okay? Side lengths are the same, but they don't meet at whatever, 90 degrees. So here, the question is asking us for equivalent vectors. So we need to look for the same size, but also in the same direction. It's very simple, actually. It's just, you just look at it. It's a 5-second answer. Let's look at AB. AB is going from here to here. It's going in this direction. Which other vector is doing the same thing? We know all four of these side lengths are the same because it's a rhombus. Now we just need to find another vector that's going in the same direction as AB.
DC.
DC, done, easy. DA, where's DA going? DA is going this way. What's the equivalent vector?
CB.
CB, easy peasy. EB is going, where's EB? EB is going straight up. The only one that's going straight up is DE. The last one is AE. What's the equivalent of AE?
EC.
EC, done. It's a very basic. State 4 pairs of equivalent vectors. Very simple question. BC is equal to AC, or sorry, AD. So this is equal to this. AB is equal to DC. So we did up, down, left, right, and then we can also work on the diagonals. AE is EC, and EB is DE, right?
Mm-hmm.
So those are the equivalent vectors. Part B, state 4 vector pairs of opposite vectors. Now, opposite vector is like this. Let's say you have this vector A. It's going east, and the distance is 2 units. Opposite vector needs to be the same magnitude. So you can have something like this. This you can call it B. The magnitude has to be the same, but the direction has to be completely opposite. If this is going east, where should vector B be going? It's going to be going west. Otherwise, they would not be equal. So here, this you can also rewrite this line as vector B is the same thing as vector A, except it's in the opposite direction, negative a. So that's the definition of a opposite vector. Same magnitude, but different direction. So for part B, it says state 4 pairs of opposite vectors. It's pretty simple. You can say AB is equals to CD now, CD. They're equal because it's a square, looks like a square, rectangle, whatever it is. The side lengths are the same. AB is going north, CD is going south. So that's why they are equivalent. What's another opposite vectors? Another pair of opposite vector. See AE, look at the diagonal. AE, it's going this way. EC is the exact same thing as AE, so they would not be opposite. But instead of going EC, what if we go CE? What if we go down this way? Southwest. So CE would be the opposite. A is going this way. EC is the same thing, but CE is going backwards. So that would be the opposite, okay?
Mm-hmm.
Part C, state 2 pairs of vectors whose magnitudes are equal, but whose directions are perpendicular to each other. I mean, again, we're just looking for vectors with equal lengths. So we can say this and this because that's 90 degrees. So we can say AB is perpendicular to AD, and we know their magnitudes are the same. And the other one is, there's multiple, BC and DC. And you're done with this question. It's pretty basic. Okay, this one's also very simple. It says, given the vector AB as shown, draw a vector equal to AB. Equal means it has to be the same length and the same direction, yeah?
Mm-hmm.
So what I'm going to do is I'm going to make another vector and just assume that this is straight, CD. It's going in the same direction. Let's say it's both going northeast. So they're both going like in this direction. And the side lengths are the same like that. So AB is equals to CD. That's going to be an equal vector. Opposite to AB. How would we draw that? What would a vector opposite AB look like? So remember, opposite is the same length. Okay, what does opposite mean? Opposite means same magnitude. Length and magnitude mean the same thing. Same magnitude, but different directions. That's what opposite means. Opposite means, in fact, 180 degree, but 180 degree difference. 180 means a U-turn, like this going this way, this way. 180 degree difference in direction. So for part B, if AB is going that way, opposite to AB will be BA. Look at this. BA is going this way, yeah? Opposite to AB, you can say it's BA. Or you can just make a new vector here. Call it CD or whatever. But the direction has to be going southwest. So that'd be the answer to B. Part C, whose magnitude equals AB, but is not equal to AB. What do we do in part C? No?
It can't be the same direction.
Exactly. There's an infinite number of answers. So I'm just going to draw the same thing, except it's going up. And that's it. Side lengths are the same. Part D, whose magnitude is twice that of AB and in the same direction. Again, very simple. You just extend this twice as long. So let's say
What
this,
do the two lines mean? Like
it means the
beside AB?
magnitude. It means the magnitude. Okay, let's see what
Okay.
that means actually. I'll show you what that means. So let's say this is 3, 0. Let's say this is 0, 4. Okay, as a coordinate system. On a coordinate system, let's say this is 3, 0, this is 0, 4. AB means the length or the magnitude. The technical term is the magnitude, but it means the same thing as length. What's the length of AB? That's what that symbol is. Let's turn this into a triangle. I'm gonna change some parameters. I'm gonna start A at 0, 0. Let's say this is 0, 3. Or it can't be 0, 3. Let's say that's 3, 0. And let's say this is 0, 4. All right, there we go. So these are our coordinates. What's the distance from A to this point?
3,
What's the distance? What's the vertical distance?
4,
4. What's the length of this hypotenuse? We have 3 here, we have 4 here. Pythagorean triples,
5.
5. AB would be 5. That's what it means. Use Pythagoras theorem to find its length.
Okay.
That's it. All of this is pretty simple. E, it says magnitude is half, so you flip it in the opposite direction. That's it. It says the opposite vector. The only thing that's going to change is the direction. It's going to flip 180 degrees. That's it. Opposite means direction flipped, flippity, 180. So for part 8A, it says airplane flies due north at 400 kilometers per hour. What's the opposite?
It's going to be flying south.
That's it, south here. Car travels northeastern, so it's going to be southwest. Northwest, it's going to be southeast. West, it's going to be east. That's it, and you're done. I'll show you why northwest is southeast. Northwest goes this way. The opposite of that is this, which is going southeast, right? Just flip it 180. It's very simple. This one's going to be tricky. So we are given some lengths. AB is 3, which means DC is automatically 3, which means EF is automatically 3, which means HG is automatically 3. What else have they given us? AE is 8. All right, so if AE is 8, which other sides are 8 units in length?
HD, and then GC.
Right, so this, and because it's a square, all of these sides are also 3. It's a square base prism. So the base is a square, like that. So that's what we have. I'm just going to make this a little bit cleaner. So just remember, these 4 down here are 3. And these are 8 units, all of them. All right, so that's our sketch. State whether each of the statements is true or false. AB is equals to GH, true or false?
Yes.
False. AB, the vector, is not equal to GH. Why not?
The directions are
The
different.
direction is the opposite. The magnitude would have been the same. If we had the square brackets here, yeah, that would be true. But GH is going the opposite of AB, so that's false. The second one here is asking you for the magnitude. Remember that square thing? We don't care about direction. We're strictly concerned with the length. EA, where is EA? This way. It's 8 units. Is CG. True or false?
True.
True. AD is DC. AD is going this way. DC is going this way. True or false?
True.
True, because we're talking about the magnitude. It's a square base prism. True. The last one's a vector. AH. This is going to be tricky. AH is BG. All right, so let's come up with these. AH, I'm just going to erase these numbers. They're irrelevant. AH is going to be this vector here. That brings you from A to H. Remember what a vector is. Vector is just something that brings you from one position to the other. So there is no direct connection between AH. What we need to do is we need to follow the shape of the object. So look at this. You can rewrite AH as this. AH is equals to AE, and again, the direction is important. To get to H from A, first you gotta go to E. So AE, and from E, where do you go?
The 8.
EH. So that's AH. Now we're gonna do the same thing for BG. BG. So it's this one. For BG, we would go to, there's multiple ways. You can go BF, FG, you can go BC, CG. Because last time I went up, now I'm also gonna go up. So BF plus FG. Now the question is AE and BF, are these two equivalent? They are, right?
Mm-hmm.
AE and BF, they're both going up and they're both 8 units. And EH and FG. So EH is going this way, FG is going this way. They're both 3 units. Are the directions the same?
Yes.
Yes. So therefore, because both of these components are true, this must be true. B. Calculate the magnitude of BD. All right, where is BD? BD is here. You don't need vectors to do this. Remember, it's a square, so all angles are 90 degrees, and we know they're equivalent. What's the unit of, well, how big is BD? How do we find BD?
It's the square root of 18.
Correct, yeah. Square root of 18 is square root of 2 times square root of 9. Remember perfect squares? It's 3 root 2. BE might be a little bit more difficult to visualize. I'm gonna draw this face. So we're looking at, you're here, basically your eyes are like here. We're looking at it this way. So I don't know why you have horns. So BE. So we're just gonna flip this diagram. So this is E, F, B, A, like that. And we want to find BE, so this right here, the magnitude of it. We know AB is 3 units. We know AE is 8 units. Is this a right angle rectangle here? This one? This face?
Yes.
Yeah, so this right here is 90 degrees. So therefore, BE is going to be 64, 8 squared, plus 3 squared, 9. It's going to be the square root of 73, which I think is a prime number, can reduce. And that's that. BH. BH is going to be very tricky. All right, let's see if we can decipher BH. So we need to go from here to here. Yeah, like that. I'll give you a hint for this.
BD.
BD was root 18 or 3 root 2. So let's draw this. This is what it's going to look like. That triangle we're looking for BH. This is BD, which we know is root 18. And DH is 8 units. So BH is going to be 18 squared, so that's just 18, plus 8 squared, that's 64. What's that? Square root of 82, whatever that is. 9 point something. And you're done. Cool?
Mm-hmm.
So you're just trying to find patterns. That's what it is. It's pretty simple, honestly. Here, let's try doing this. This will make it clear what we're actually doing. Remember, vector, all it is it brings you from one position to the other on the plane. Yeah. So AB is a vector which has a tail at -4, 2. So 1, 2, 3, 4, -4, and 2. So right here is a tail of AB, and its head is at -1 and 3, right here. So this is our vector AB. -4, 2 to -1, 3. All right. Calculate the magnitude of AB. How can we find this? We're looking for the hypotenuse of that triangle, essentially, is what we're doing. We're just looking at here's our triangle. We're looking at the hypotenuse, its length. What would that be? So think of it this way. How many units run? We're going from -4 to -1, 3 units.
3.
The rise is 1 unit, right?
Mm-hmm.
From 2 to 3. So what's the hypotenuse? Square root of what?
10.
10, done. B, determine the coordinates of point D on the vector CD if C is -6, 0. All right, so now this is complicated. It's honestly not that complicated. You just have to follow the pattern. It looks complicated though. C is -6 and 0, so we're right here. This is -6, and that's our C vector. That's the tail. But now we need to find a vector D. What would that be? And this is how it works. We know CD is equivalent to AB. So now you have to think of it this way. What brings A to B? How do you go from A to B? To go from A to B, you go
You go across by 3 and then up by 1.
exactly. So we're gonna do the same thing for this point. This is gonna go across by 3, 1, 2, 3. So it's at -3 right now, and it's gonna go 1 units up right there, and that is CD. Okay.
Mm-hmm.
Where does it end up? It ends up at -3 and 1. That's the head of D. Okay, we skip C. C is the same thing. Let's go to D. Determine the coordinates of point G on vector GH if G is this, yada yada. So we're looking for GH. And G is at 3, 1. So 1, 2, 3, and 1. This is G right here. And it says GH is the opposite of AB. So it's going in the opposite direction. So it would not be going here, okay? Because that's where AB was going. It's not gonna go in that direction. It's gonna go southwest. It's gonna go in this direction. And you go, it's the opposite, right? Look at this. You go 3 units across, 1 unit up. The opposite movement would be what? You go 3 to the left, right?
And then 1 down.
1 down. So you go 3 to the left and 1 down. You end up at the origin, essentially, is what it is. Right there. Cool?
Mm-hmm.
Did you do trig? You did trig, right? Did you do sine law, cosine law? I know we did it. Did you do that in class?
We did sine law.
All right, cool. Cosine law is the same. Well, it's not the same thing, but if you understand sine law, cosine law is not that hard. So let's try this one. And this one, you have to really think of it. You're given two vectors, A and B. You're given their dimensions or their magnitudes. One is 3 units, the other is 2 units. The question is, what's the sum of the magnitude of A plus B? And I'll tell this to you right now. It's a very, very common mistake. The answer is not 5. Everyone's like, the answer is 5. No, it's not 5. Because there's an angle between them. If they were both in the same direction, then the answer would be 5. If this was A, 3 units, and this was B, 2 units, then A plus B would be 5. That's fine. But here, they're not going in the same direction. They're going in completely different directions. A is going somewhere with 3 units, and the angle between A and B is 60 degrees, and B is going this way at 2 units. The question is, what's A plus B? All right, now this brings us to this, which is the vector fundamentals. To add vectors, okay, to add vectors, you can only add them. You can only add them tip to tail. Tip means these. Tail means these. Right now, this sketch, the question, has it connecting these two vectors from tail to tail, yeah?
Mm-hmm.
Tail to tail. That's no good. You can't have tail to tail. So you need to have head to tail. So how do you do that? You need to move this a little bit around. This is what we did last time when we sketched the new triangles. What we do with this one is we move either one of them. It doesn't matter. You can move B over here or you can move A over here. It doesn't matter. I'm going to move B. So our new sketch is going to look like this. So this was our original B. This is going to be our shifted B. It's because A is going this way, and now I've moved B over here. So now the tip of A is touching the tail of B. And that's how it should be when we're trying to add two vectors. We know this is 3 units, and we know this is 2 units. The answer to this problem is this. That right there is A plus B. Because you can only add vectors from tip to tail. Now think about this. Think about this in terms of a parallelogram. The angles in a parallelogram are supplementary or complementary. They add up to 180, essentially, is what I mean. They always add up to 180, and overall they add up to 360. So if this is 60, what is this angle here? It needs to add up to 180. It's going to be 180 minus 60, yeah?
Mm-hmm.
Which is what?
120.
120. So that angle there is going to be 120 degrees. Now, how do you solve for A plus B in this triangle? Can you use SOHCAHTOA?
Yeah.
No, you can't. SOHCAHTOA is strictly for right angle triangles. This is not a right angle triangle. In fact, this is not even an acute angle. This is we've gone too far. You cannot use SOHCAHTOA here because it's not a right angle triangle. So what do you do then? You can either use sine law or you can use cosine law. They both have restrictions on when you can use them. Sine law you'd use when you have a pair. By pair, I mean the opposite side length and its angle. The opposite side length and its angle. The opposite side length and its angle. Here, you don't have any pairs. So this is not a sine law problem. This is a cosine law problem, okay? It's a cosine law problem. What does cosine law say? Cosine law says this. We don't need this. Let's say you have a triangle, and it doesn't have to be 90 degrees. I'm gonna call this whatever. This is C, this is side length A, this is side length B, and this is capital angle C or theta. Let me just call it theta. So that is theta. This is what the cosine law says. C squared, this opposite side from that angle, is equals to a squared plus b squared minus 2abc squared. Sorry, not 2abc squared, minus 2ab cosine of theta. There has to be a cosine somewhere because it's the cosine law problem. So there we go. That is the equation. Let me just double check that. 2ab, right? Yeah, 2ab. All right, now we're going to use this formula to answer this problem. Look at this. Magnitude of a plus b squared is equals to a squared, so 3 squared, plus b squared plus 2 squared, minus what? Minus 2 times what? I'm just following this formula right here. So
Minus
this,
3.
yeah, 2 times 3 times 2 times cosine of what?
120.
120. There we go. And then you square root. Remember, we're trying to find the magnitude of a plus b. There's a squared here. There's a squared here. You have to square root this, and that'll give you the final answer. Make sure you're in degrees. So square root of 3 squared plus 2 squared minus 2 times 3 times 2 times cosine of 120. I got 4.09. And that's the answer to this question. Cool?
Mm-hmm.
I did not unplug that. What did I get? I said 4.09. 4.36. Plug something in wrong? 232. Okay, yeah, I see it. I see it. I plugged something in wrong. But that's the steps. Everything is good, except the calculator bit at the end. So to add vectors, it has to be tip to tail. This is called the parallelogram law, and that's what we use to add vectors. Now that you might be wondering, okay, adding vectors makes sense. That's cool and all. How in the world do we subtract vectors? Let's do the same problem, except now we're going to subtract them. So this is how we did it when we added them. Now we're going to do the same thing, except instead of determining a plus b, we are going to determine magnitude of a minus b, like that. Now, how does this work? What you do with something like this is this. You're going to rewrite that as a plus negative b. You're still going to do tip to tail, but instead of adding b vector, you're going to first flip the b vector because now we have the negative b, which means it's an opposite vector. You have to first flip it, and then you have to redraw it. Okay, just to recap, last time we had something like this. That was A, and this was B, and this was the angle. What we did was we moved B to the other side, and we found this. And this angle became 120. That was A plus B, tip to tail. To do a subtraction problem, we're again going to start from A. So let's say A is going in the same direction, like this. That is 3 units. But now, instead of adding B vector, the positive B vector, which is still here, this is B vector, the angle is 60. Instead of adding this vector, we're gonna add negative B. Check this out. This is B. Negative B would look like this. Do you agree?
Mm-hmm.
And we need to add this. It's always tip to tail. Even when you're subtracting, it's tip to tail. The only difference when you're subtracting is first you have to flip the vector, the negative vector. So I'm going to add this here, like that, B vector. Use the parallelogram law, or just use the Z law. This line and this line, they're essentially the same line. They're parallel. If this is 60 degrees, what is this angle?
60.
60. That's A. This is now negative B. And we're going to connect A to negative B from here to here. There we go. That is A minus B or A plus negative B. Alrighty, so now A is still 3 units, B is still 2 units. Length can never be negative. Now, how do you find A plus negative B? Well, it's the same thing as last time, except now the angle is 60. That's the only difference. A plus negative B is the magnitude of this squared is equals to A squared plus B squared minus 2 times A times B times cosine of that angle that we're trying to find. The angle should always be the opposite angle of the side length that we're trying to find. So here it's going to be 60. And you square root this, and that'll give you the final answer. And that's how you do negatives. So adding and subtracting vectors, you need to turn them into parallelograms and use the cosine law. Cannot use sine law because you will not have a pair. Cannot use SOHCAHTOA because there are no negative angles. Or right angles, sorry. Right angles. Representing a combination of 3 vectors using the triangle law of addition. All right, so we're trying to find A minus B plus C. You can do this in any order. They're commutative. But I'm going to do it in the order that they gave us, A minus B. So let's first find this. A is going this way. B is going this way. And remember, you have to add a tip to tail. But we're not trying to add B. We're trying to add negative B. Might as well write it like this. A plus negative B plus C. So this is positive B. It would go this way. But we're not trying to add positive B. We're trying to add a negative B. So this is our direction like this, okay?
Mm-hmm.
This is A, that's negative B. And then you can either do this in one shot or you can do this in multiple steps. If you want to do it in one shot, you're going to add C, the tail of C, to the tip of negative B. So you would add it here like that. And the final answer is going to be your starting point, and you connect this to your end point. Like that. And that would be the final answer. That right there is A minus B plus C, the vector. So that's one way of doing it. You can do this in one shot. If you want, you can do this in 2 steps. First step, you find A plus negative B, which is going to be this one right here. So this is A plus negative B, and to this you want to add C. So like that. And then the final vector, again, connect where you started and where you ended up. And this is what you get, which is what this is. So that's how you can add multiple vectors. I prefer this way. You can just add everything in one shot, because all you have to care about this once you line them up is where you started and where you ended up. And if you do this using a ruler on a graph paper, it's very precise. It's a question that's somewhat difficult. So OA, so they've given us 3 vectors, A, B, and C. They all represent these 3 sides. Direction matters. Question is, express each of the following vectors in terms of A, B, and C. Alrighty, so let's look at BC. BC is where? BC is here, this way. How can we express BC in terms of A, B, or C? Which one is it most similar to? I think it's most similar to A, right? BC is on the same plane. How do you write BC in terms of A? It's the opposite vector.
Negative A.
Negative A. BC is going to be negative 8. That's it. GF is the same thing. What about GF? Is it A or negative A?
It's A.
It's A, and because it's a prism, all the side lengths are the same. Like this, this, and this would be the same. This would be the same. This would be the same. So that GF up there is the same thing as A down here. OB. Now it's a little bit tricky because now you have to combine vectors. OB is going this way. So OB is what plus what? You can write that as a combination of two vectors.
OC plus CB.
Okay, OC plus CB, and OC is denoted by C. What about CB? Which vector is CB?
A.
A, exactly. And there you go. That's the answer to OB. Part D, AC. Or where's C? C is right here. You can follow multiple paths. So you're trying to go here. You can either do a pit stop at B or you can do a pit stop at O. Both of them are fine. So let me show you both ways. AC is either AB plus BC, which would be vector B plus what? How do you denote BC?
Negative A.
Negative A. Or you can go this way, where you can say AC, well, it's AO plus OC. The answer would be the same. AO is negative A and OC is B. Since we're adding them, the order doesn't really matter. Last one, OF, or actually BG. Okay, let's do BG is fun. So we're here, we need to end up here. What plus what?
BC plus CG.
That works. BC plus CG, and BC is negative A. What about CG?
C.
CG is simply C. Yep. The last one there is OF. Where is F? It's all the way over here. So we're starting here, going all the way over here. And again, you have to make multiple pit stops. So OF can follow any path. I'm going to follow the most convoluted path here possible. I'm going to go to C first, OC. Then I'm going to go from C to B plus CB. And then finally we go from B to F. OC is vector B, CB is vector A, and BF is what vector?
C.
C, there we go. So the answer is A plus B plus C in any order. The order, again, doesn't matter when you're adding them. All right, so there's a plane. It's going this way. So this is our plane. It's going this way at south, right? You know your directions?
Mm-hmm.
Like that. So south is down. So it's going at 300 kilometers per hour this way. It meets a wind from the west. So wind is coming from the west. How would we denote this? Would we denote it case 1 or case 2? Wind from the west. Which one makes more sense?
1.
1. So it's coming from that direction, and the wind is pretty gusty. It's 100 kilometers per hour. It's not abnormal, by the way. This is perfectly fine. Which layer of the atmosphere does a plane fly on? Do you know that? Which layer has ozone? Ozone as in O3. Heard about this?
Mm-hmm.
It's the stratosphere. Again, that's not super important. It's the stratosphere. In the lower part of the stratosphere. sometimes you can actually smell ozone when you're in the plane. It is a greenhouse gas. But up there, the ozone is continually absorbing radiation from the sun, so it kind of burns itself out. What was my point? I forgot what my point was. Anyways, it flies in the stratosphere. Why? Because the air is thinner there. Air is thinner means plane requires less energy to keep the lift. Oh yeah, this was my point. You might be wondering, well, that's a very high wind speed, right? 100 kilometers per hour. This is actually not that much. Up there at those heights, you have something called polar jets. Maybe you can look at this into later. Polar jets. These are super quick and they can go all the way up to 500 kilometers per hour. It's very fast. So basically the point is turbulence on a plane is normal and expected. Sometimes it can be pretty bad, but you're fine. Turbulence doesn't bring a plane down. Not to say that it hasn't. It shouldn't. If you have a good pilot, then yeah, turbulence is whatever. Anyways, it's coming from the west, plane's going south. What is the resultant velocity of the plane? Okay, here's a question for you. Is the answer 400? Because there's 300 going south and the wind is coming 100 from the west. So the answer should be 400. Is that right?
No.
No. Why not? It's all about the what? It's all about the theta. It's all about the angles, right? If they were going in the same direction, then it would have been 400. But the fact of the matter is they are not going the same direction. What's the angle between south and west? What would be this angle?
90?
90, right? Can you use SOHCAHTOA?
Yes.
Yes, perfect. So there we go. This is a SOHCAHTOA problem. But again, since we're dealing with vectors, we're given a speed with direction. So we're dealing with vectors. So we need to do the tip to tail. So what I'm going to do is I'm going to move this. You can do this. I'm going to show you both ways. It doesn't matter. The order doesn't matter about vectors. That's the beauty of it. You can move this over here. So it would look like this. It's 90 degrees. This is 100. This is a 300. This is your resultant vector right there, which is going to be what? 300 plus 100. Yeah, agree with that?
Mm-hmm.
At the same time, we could also move this down here. So we had this, we can move this down here. This is 300, this is 100, it's still 90, it's still SOHCAHTOA. And you'll notice that this is the exact same thing as this. We drew different, but it's the same. They represent the same thing because the order, vector addition, the order doesn't matter. So that would also be 300 plus 100 squared. Let me plug that in. So 300 squared plus 100 squared, it's not going to be even close to 400. So what is this answer? 316. So the answer is 316 kilometers per hour. Make sense? Did we answer the question? What do you think?
The direction's not there.
The direction's not there. We're talking about a velocity, so we need to have the direction. So now the question is, which direction do we find? What's the best angle to find? It honestly depends. It depends on how you want to label your system. I'm going to focus on which one would be the easiest. I'm going to focus on this one. In our triangle, that triangle, again, this is up to you. You can position this wherever you want. I'm going to position it at the origin because it's the smart thing to do. That's the easiest thing to do. Right there. We know this is 316. We know this was 100. We know this is a 300. What I'm going to do is I'm going to find this angle. We know this is a 90 degree. Yeah?
Mm-hmm.
I'm going to call that theta. I'm not going to use this because that's not the precise answer. There were some decimals in there, which I forgot what it was. So I'm not going to use this. I'm not going to use the hypotenuse, which means I can't use sine or cosine. You can use this, okay? It's just the most precise answer here would be if you use these two numbers, because this was an irrational number, and unless you have saved the answer, it's not going to be the precise answer. I'm going to do tan. Sine and cos doesn't work because I don't want to use the hypotenuse. So theta is tan inverse of what over what?
300 over 100.
300 over 100. So that's tan inverse of 3. Make sure I'm in degrees. I'm in gradients. Tan inverse of a 3 straight up. So that's 72 degrees. Again, this is the angle that I found, right? 72 degrees. And
Mm-hmm.
look at how I'm going to label this, okay? So the resultant velocity is 316 kilometers per hour. This angle, first you go east, you go right, you go east, and then you do 72 degrees south. That's how you'd answer this. Alternatively, okay, here, look at this. If this is 72, what is this angle here? If this is 72, what's a small angle? Quadrant adds up to 90.
It's 18.
It's 18. So now another way to answer this question, the magnitude will never change. It's still 316 kilometers per hour. But now look at this. For this angle, which is this diagram here, for this angle, you have to first go south. So it becomes south 18 degrees, and then you kind of twist it this way, east. There we go. So both of these, they represent the same thing, okay? Both of them, they represent this vector here, this vector. It's just different ways of calling it. That angle is also this angle here. It just depends on where you place it on the grid, coordinate grid. And that's the answer. So that one, you can definitely use SOHCAHTOA because it is a right angle triangle. So yeah, the E 72 degrees, 71.6 south. So that was the big angle here. Or you can also go 18 degrees this way. And then there's a third way you can do this, which is the worst way, I think, is you can use a bearing. A bearing is always strictly from the north. So again, our sketch down there was like that. This was the wind, this was the plane, this was our sketch. This angle was 72 degrees, yeah? When you talk about bearing, you don't have to worry about east, north, south, west, whatever. But bearing always comes from the vertical, from this direction, like this. So what's our bearing going to be here? That's going to be 90 plus 72, 161.8 or 162. That's what they have here. Bearing is always from the vertical. Did that make sense?
Mm-hmm.
Okay, here's a question for you. A and B, the final answers, will they be any different? We're just adding vectors. Yeah. The question is the answer to A and is the answer to B going to be any different?
No.
No, why not? Because the order doesn't matter, okay? Because we're adding things. Vectors are commutative, which means the order doesn't matter. You know what I mean by commutative? I don't know if I've just been babbling. This is what I mean. A plus B is B plus A. Commutative. So these two will be exactly the same. They are the same, no difference. The order doesn't matter. Same thing with the multiplication. If you multiply, the order doesn't matter. You can multiply 3 times A times 2 or 2 times A times 3. No difference, commutative. Which one seems very difficult? We have time for one more. I'm just gonna do this one. Hopefully it's tricky. We will do one or two of these. Let's do QZ. QZ. We're here. We need to end up here. How do we get there? There's multiple ways, yeah? You can go this way. So QR plus RZ. QR is negative X. Do you agree with that? QR is negative X because X is going this
Mhm.
way. So negative X. RZ is negative Y. There we go. That's the answer to QZ. But the beauty about vectors is this. That's the best way to do it. That's the easiest path. But you don't have to take the easy path. If you wanted to, you could do it like this. QZ, you could be like, you know what? It's QB plus BY plus YO plus OX plus XB plus BY plus YR plus RZ. You see this?
Mhm.
You can take this long path. Eventually what's going to happen is some of them are the same. And once you do this, whatever you're left with is exactly the same thing as you found before. So the order doesn't matter. Final answer will always be the same. So they're kind of easy to work with. That's a good thing about vectors. All right, let's call it there for today.
Okay, thank you.
See ya.